Okay guys, second video for chapter 19. So more about significance tests. So we spoke about first starting with making our claims. What are our hypotheses? This video will concentrate more on what we're measuring in our significance tests. So significance tests ask if sample data give convincing evidence against the null hypothesis and in favor of the alternative hypothesis. A test answers the question, how likely is it to get a result like this just by chance when the null hypothesis is true? So we've seen similar ideas in our sampling distribution chapter in chapter 17. So we would be asked a question like, is this surprising? So we'd have to find our probability of our sample, let's say, proportion being true, given that a certain population proportion would be true. And if it was a really, really small number, we understood it as that was unlikely to occur if the actual proportion for the population was what it was given. Okay, so these are very closely related to that idea. Answers will come in the form of a probability. So evidence is convincing if the null hypothesis is correct and just by chance a very unlikely outcome occurred. The alternative hypothesis is correct, the population proportion is incorrect, and the sample result is not an unlikely outcome. So the basic idea here, guys, an outcome that would rarely happen if the null hypothesis were true is good evidence that the null hypothesis is not actually true. So if you have a probability that would show an outcome would rarely happen, then we're going to say that the null hypothesis is not true. Okay, so now we're gonna talk more about the actual measurement here. So a p-value is going to be our probability that will help us measure the likeliness of our alternative hypothesis occurring when our null hypothesis is true. So the null hypothesis states the claim that we are seeking evidence against. The probability that measures the strength of the evidence against a null hypothesis is a p-value. So the probability computed, assuming the null hypothesis is true, that the statistic would take a value as extreme or more extreme than the one actually observed, is called the p-value of the test. The smaller the p-value, the stronger the evidence against the null hypothesis provided by the data. So small p-values are going to be evidence against the null hypothesis because they say that the observed result is unlikely to occur if it were true. Large p-values fail to give convincing evidence against the null hypothesis because they say that the observed result is likely to occur by chance if the null hypothesis is true. Okay, so just an example to kind of help us understand what the p-value tells us. So I'm going back to the job satisfaction example that was at the end of the first video. So we know we had a null hypothesis that had a mean of 0 and an alternative that was not equal to 0. It was a two-sided test here. So data from the 18 workers gave a sample mean of 17 and a standard deviation of 60. That is, these workers rated the self-paced environment on average 17 points higher. Researchers performed a significance test using the sample data and found a p-value of 0.2302. So explain what it means for the null hypothesis to be true in this setting. In this setting, the null hypothesis says that the mean difference in satisfaction scores, that's your self-paced minus your machine-paced, for the entire population of assembly line workers at the company is 0. If the null hypothesis is true, then the workers do not favor one work environment over the other on average. Now let's interpret that p-value of 0.2302. So because the alternative hypothesis is two-sided, the p-value is the probability of getting a value of x bar as far from 0 in either direction as the observed x bar 17 when the null hypothesis is true. That is on average, that is an average difference of 17 or more points between the two work environments would happen 23% of the time just by chance in random samples of 18 assembly line workers when the true population mean is 0. So an outcome that would occur so often just by chance when the null hypothesis is true is not convincing evidence against the null hypothesis. So we would fail to reject the null hypothesis. Okay, our evidence is not good enough to prove that our null hypothesis not be true. Okay, so the final step in performing a significance test is to draw a conclusion about the competing claims you were testing. So what happened? Were we right about the null hypothesis, or were they right about the null hypothesis, or were we right about the alternative hypothesis? We will make one of two decisions based on the strength of the evidence against the null hypothesis and in favor of the alternative hypothesis. So we're going to say it very simply as either rejecting the null hypothesis or we are going to fail to reject the null hypothesis. If our sample result is too unlikely to have happened by chance, assuming the null hypothesis is true, then we're going to reject the null hypothesis. Otherwise, we will fail to reject the null hypothesis. So these are the ideas that go on in our court system, okay? So you ever notice that a jury will not say not guilty, or they say not guilty. They won't say that you're innocent, okay? So that means that the evidence is not strong enough to prove that they're guilty. They may not necessarily prove that they're innocent. They're just not able to prove that they're guilty. Okay, so a way of thinking of that too would be if somebody has really strong, valid, or reliable alibi, then they're no longer even a suspect. They wouldn't even get to trial. So if you knew somebody was innocent, they wouldn't even get there. So in a court system, they'll always say, or a jury would say, that they find them not guilty rather than they find them innocent. So it's very much the same here. You're not necessarily saying that the null hypothesis is definitely true. It's just that you don't necessarily have the evidence to prove that it's guilty. So a fail to reject the null hypothesis decision in a significance test doesn't mean that the null hypothesis is true. For that reason, you should never accept the null hypothesis or use language implying that you believe the null hypothesis is true. You just don't have good evidence to support your alternative hypothesis. So you can't, it's almost like you can't show your alternative hypothesis is true. But that doesn't necessarily mean that your null hypothesis is true. It could still not be. So in a nutshell, our conclusion in a significance test comes down to if you have a small p-value, you're going to reject your null hypothesis. You'll conclude that your alternative hypothesis is true. But in a in a larger p-value, you're going to fail to reject your null hypothesis because you cannot necessarily conclude that your alternative hypothesis is true, at least not from the evidence that you may have. Okay, so another real quick idea is the idea that significant in the statistical sense does not necessarily mean important. It means it simply not likely to happen just by chance. So we've spoke about that before in our class. And that's it for our second video. One more.